Here's another example, and this is a number 3. A fossilized piece of wood contains 23% of the normal amount of carbon-14. The half-life of carbon-14 is 5,600. How old is the fossil? So, again, we're going to use our same basic formula. The amount at any time t equals the initial amount times e to the kt. All right? There we go. Excuse me. Right. And the initial amount, we don't know the initial amount. We know we have 23%. How old is the fossil? So we're going to have our ratio is going to be 23%. So we want to know the time. So we have to figure out the k first of all. So we don't have very much, we don't have the initial amount, but we know the ratio is going to be 23%, so we can figure it out from there. So that's going to reduce that variable. But first of all, we've got to find the k. So I know that again, like the last problem, the ratio of the amount I have over the ratio of the amount I had over what I started with is going to be 1/2 or 0.5, and that equals e to the kt. And in this case, that's going to be 5,600 years. All right, so for carbon-14, it's 5,600. So let's think about the last problem. Okay? So the half-life of carbon-14 is 5,600 years. So that's going to be the time for me to have a ratio of 1 to 2, or 1/2. Okay? So that's going to allow me to find my k. So I can take the natural log of both sides. The natural log of 0.5 equals the natural log of e to the k times 5,600. Write that 5,600 up here. Okay. And if this is too small, you can always zoom in. As a matter of fact, I should zoom in a little bit more like that anyway. See a little better. Pardon me, I should have done that earlier. Okay. All right. And then we can bring this in front. So I've got the natural log 0.5 equals 5,600 k natural log of e, which goes to 1. So k will equal the natural log of 0.5 divided by 5,600. Okay? Now I can put that in my equation now, so I can have a general equation for this particular situation. Carbon-14, I should say. $5,600 T. All right. So now if we know what the time is and our initial amount, we can figure out how much we've got. If we don't, if we have a problem like this where they don't give us the initial amount but they have the ratio, then we can still find it because we have 3 open quantities here, but by using a ratio that reduces these two to nothing anyway, to 1. Just reduces these two to a percentage. So I know that the ratio I have of the amount to the amount I started with, and remember the amount you started with is the same as the amount of carbon-12 in the fossil or the piece of wood, because that doesn't change. So the carbon-12 stays the same, the carbon-14 decays, so they'd use the carbon-12 as a guide to how much carbon-14 we initially had. So we know that that ratio is 23%. And what's left over here is just e to the kt. And then you only have one unknown, so you can solve this. So just take the natural log of both sides. Now I can bring that in front. 0.23 equals the natural equals natural log of 0.5, 5600 t. That whole thing goes in front times the natural log of e, but the natural log of e is 1. So this is what we got. So in order to solve for my time, I just multiply both sides by 5600. 23, excuse me. And divide by the natural log of 0.5. Move this up so you can see that. So that's 2300. Try to clean that up a little bit. And this is the typical type of problem that we do when we're doing carbon-14 dating. So we see this problem a lot, so this is one you want to really be up on. You always go back and review these, slow them down. You can zoom in if you want. Okay, so that's 2300. And then you just put this in your calculator. So, and that'd be pretty easy. Just put parentheses because you got a fraction. And either calculator would be the same. So just parentheses, 5600, natural log of 0.23 divided by natural log of 0.5. See what we get. Oops. Got to put a parentheses around the top of my fraction. So I got a fraction. So the top has got 5600 natural log of 23 0.23 divided by natural log of 0.5, and we get 11,876. 11,873, excuse me, 0.65 years. So 11,873.65 years is approximately the age of the fossil. Okay? As you can see that, all right? And that's how you put in your calculator. Okay. So that's a standard type of problem, so that's one you definitely need to be able to handle.